In this lesson, we're going to go over concurrent lines. So starting off, a concurrent line or lines are just three or more lines that will meet at one point. Your point of concurrency is going to be the point at which those concurrent lines intersect, they cross. So we've got four of them that we're going to talk about. The first one is going to be our circumcenter. So a circle is circumscribed about a polygon when the vertices, so the angles of the polygon, are on the circle. Okay, so I'm going to pause the video real quick and I'm going to draw our circle so that it's circumscribed about the triangle. Okay, and so this is what it's going to look like. So moving on, we have the circumcenter of a triangle is the point of concurrency of the perpendicular bisectors of the triangle. So when you draw all three perpendicular bisectors where they meet, that is going to be called your circumcenter. And so in this picture here, it's going to be that point R. And so we have a theorem that goes with this. The perpendicular bisectors of the sides of a triangle are concurrent at a point that is equidistant, so same distance from the vertices. Okay, so what does that look like? Well, in this picture here, that's going to be from R to C will be congruent to my R to A, as well as R to B. Okay, so all of those lines are going to be congruent. And so just to explain why, since we have that circle and they are all going from the center of the circle to a point on the circle, those are called our radius. And so that's why they are all going to be the same. Okay, so now let's look at our next one. We have the incenter. A circle is inscribed in a polygon if the sides of the polygon are tangent to the circle. Okay, so we haven't quite learned what that word means, tangent to the circle, but just going over it real quickly, it means it's going to touch the circle at one point. Okay, so I'm going to pause the video real quick and I'm going to draw so that we have a inscribed circle here. All right, so this is what an inscribed circle would look like. And so going back to what we have the incenter of a triangle is the point of concurrency of our angle bisectors in the triangle. So there is a theorem that goes with this one. And so the bisectors of the angles of a triangle are going to be concurrent at a point that will be equidistant, so same distance from the sides. Okay, so looking at our picture here, what that is saying is that from my center, so point D, to a point on that circle, so that would be from D to F, D to E, and D to G. These should all be congruent to each other. And that just goes back into what we mentioned earlier. It's because they are a radius on that circle. All right, so moving on, we have our orthocenter. Okay, so our next center is going to be the orthocenter. Okay, the orthocenter of a triangle is the point of intersection of the lines containing the altitudes of the triangle. Okay, and there's no real actual theorem that we will use to solve with this one, but the theorem just states that the lines contain the altitudes of a triangle are going to be concurrent. All right, so our last one is going to be the centroid. Okay, so the centroid of a triangle is the point of intersection of the medians of the triangle. And we also call this the center of gravity. So there is a solving theorem with this one. And so the medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex, so from the angle, to the midpoint on the opposite side. Okay, so let's look and see what that kind of is saying for this picture. So what that is telling me is that if I'm looking at, okay, I'm going to just use, for example, B to G, this line here. Okay, and if I start at the vertex, okay, so the angle, I'm going to go 2/3 of the distance of that whole line to get to my center, which is P. So that means from an angle to the center, that's 2/3 of the entire line. Well, in a sense, if we have the entire line is 1 and we've got 2/3 of it up top from the vertex to the center, that leaves from the center to a side as being 1/3, okay, because that would be the remaining part of that whole line. So we are going to use this to kind of solve, and so let's look at what they have for us. So these are just different scenarios and how you can set up to solve depending on what you're given or what you're finding. Okay, so the first one here is BP and using BG, which actually happens to be the line that I have. So we were saying that BP is 2/3 of the entire line from B to G. So in this scenario here, if you know the entire line BG, you multiply by 2/3 to get the length from B to P. Okay, so now let's look at the next one. Okay, we've got DP and CD. So let's look at the line that's going to be using those. So we've got DP and CD. That's going to be this purple line here. And so remember, same idea. From the center, okay, to my vertex, this is 2/3 of the entire line. And from my center to a point on the side, to that midpoint, it's going to be 1/3 of that line. So here, when they're looking for D to P, and we know the entire line D to C, we can take 1/3 of it to get that length DP. So DP is just 1/3 of my entire line from C to D. Now let's look at the next one. So in my next one, I'm going to use this right here because that's got my AP and my PE in it. And so once again, I'm going to label from the angle to the center, that's 2/3. And then from the center to the side, that would be 1/3 of the entire line. So here, we're trying to figure out how could I find the length from A to P if I know the length from P to E. Well, in a sense, how do I go from 1/3 to 2/3? I'm just going to multiply it by 2. So here, AP is just 2 times the length of PE. All right, and now our last one here from PG, and we've got the length of BP. So I'm going to go back to that green. My PG is that 1/3. So we're saying if we know from B to P is 2/3, how do I get from that 2/3 to my 1/3? Well, I would just divide by 2 this time. Okay, so these are just different scenarios you can use to help solve depending on what they're giving you with your centroid. All right, before we move into some solving, I'm going to come over here and I'm going to write out a mnemonic device that could be helpful for some of you in remembering which segment goes with which center. So give me 1 second. I'm going to write it out. And to do that, I'll just pause the video. All right, so the mnemonic device is all of my children are bringing in peanut butter cookies. All right, so to go through this, what it's doing is it is pairing up the segment with the center. And so what I'm going to do is just looking here, we have all of. So that all, that A, is going with the segment. Okay, so which segment do we know that starts with an A? Well, our segments are altitudes, perpendicular bisectors, angle bisectors, and our medians. So technically 2 of them do start with that A, our angle bisectors and our altitudes. But noticing that the next word starts with an O, okay, that's not going to be my angle bisector because it should be then a B. So this one here would be that altitude. Okay, so my altitude goes with, and we would think about which center starts with an O. Well, that would be my ortho center. Okay. Then we move into our my children. So my children, we're starting with the M. So we want to think about which segment starts with an M. Well, once again, that would be our altitudes, angle bisectors, perpendicular bisectors, or our medians. Well, medians is the only one that starts with an M here. Okay, so we're going to have medians. And then we have that children. Okay, so children starts with a C. There are 2 centers that start with a C. There is the centroid and the circumcenter. My trick is going to be, with the 2 C's, look at the length of the segment. My median is a shorter word, and so that's going to go with my centroid because it's a shorter one. Circumcenter is longer, and so that's going to be paired up with our longest one, which is the perpendicular bisectors. Okay, so my centroid is going to go with my medians. Then we move into our bringing in. Okay, so that is going to be, we've got our A's, which we already used altitude, so that leaves us with that angle bisector, which will work because the second word is that B. So angle bisector. And then we get into that third word is now an I, which the only center that starts with an I is my in center. All right, and so that's going to leave us with our last ones being, we got that peanut butter cookies. Okay, so P, that would be our perpendicular, and then bisector for that B. And then my C is going to be that circumcenter, because once again, like I said, looking at the length of that is way longer than our medians, and so it's going to be paired up with our circumcenter. That's the longer C one that we have. All right, so that's the mnemonic device that you can use to help you memorize, and then kind of how you use it. Moving into our first of 2 solving. So we have find the center of a circle that you can circumscribe about the triangle with the vertices. We've got 0, 0, -8, 0, and 0, 6. So I'm going to come over here and I'm going to plot those points and make them into my triangle. So I'm going to pause it and then I'll unpause with the triangle. All right, so given those points, this is the triangle that we are going to have. So they want us to find the center of which you could circumscribe. So that's going to be the circumcenter. And so remember, to find your circumcenter, you're going to want to find where your perpendicular bisectors are going to intersect. Okay, so remember, if you're given a graph, you can use the graph. If there's no graph, obviously, you're going to want to use the formulas that we know to find that. And I'll still kind of talk through those formulas as we're working through this. So starting off, we would have our first perpendicular bisector. We would want to find the midpoint, okay, because that's the bisector part. And so I'm going to start with this horizontal line down here, and I'm going to find the midpoint, which I can just count. And so that's going to be just going 4 over. So because it's a length of 8, half of that would be that 4. So my midpoint for this is going to be right here at this point. Okay. Then we would want to draw the line to be perpendicular to that slope. So the slope we currently have on a horizontal line is a 0 slope. So perpendicular to that would be a, undefined slope. I was blanking there. And so I'm going to draw a vertical line because that's what that's going to look like going through that. So let's look and see what that's going to look like. Just going to draw a vertical line through this. Okay, so this would be the perpendicular bisector for that horizontal line. Then I'm going to move to the vertical line over here on my right, and that has a length of 6. So half of that would be 3. So I'm going to plot my midpoint by just going up 3 from that origin. And so with this one, since we have that vertical line, we know that my slope is undefined. And so the perpendicular slope to an undefined is just going to be a 0 slope, which means I'm going to draw a horizontal line going through that point. Okay. And so right now I'm going to stop. I'm going to take a second and I'm going to look and see. Well, I can already see that 2 of these lines, okay, 2 of these perpendicular bisectors are going to intersect here at the point -4, +3. And so I already have my answer, because if 2 of the lines are intersecting at that point, that means that my third one, when I draw it, should also intersect through that point. Okay, and so that's actually going to answer both of our questions. Okay, so coming back over here, I can answer my first question, that my center is going to be at -4, 3. And then I can also answer the question where they're asking, explain why it's not necessary to find the third perpendicular bisector. And so I can just state what I wrote, or what I said, which is just going to be that since 2 lines intersect at that point, the third one will also have to go through that point. All right, so now we have found our answer for number 1. Now let's move into number 2, our last one, but it does have 3 parts to it. So use the figure to the right to answer the following. So in part A, and for kind of all of them, M is going to be the centroid of the triangle WOR. Okay, and we're going to find WX given that WM is 16. Okay, so I'm going to come over here. I'm going to just highlight kind of what we know. So we know that from W to M, this length here is going to be 16. And then I want to find, and I'm going to just do this off to the side, from W all the way to X. Okay, so I'm going to find the entire line there. Just drawing it off to the side though, so we can kind of see what I'm talking about. And so if I look at it, I am trying to find the entire line, and I know that from W to M is 16, which is that 2/3. Remember, it's 2/3 of the entire line. So I'm going to use that setup to kind of solve. So I'm going to come over here, and I can say that my WM is going to be 2/3 of the entire line WX. Well, plugging in what we know WM is 16. So that 16 is going to be equal to 2/3 of the entire line, which I still don't know, so I'm going to leave as WX. And what I can do is I can multiply by my reciprocal. Okay, so I'm going to multiply both sides by that 3/2. And that's going to be equal to my WX. Okay, so remember, when we're multiplying by that fraction, we are going to divide by the denominator. So 16 divided by 2 gives me 8. And then we'll multiply it by the numerator. And so when I do that, I'll have 8 times 3, which will give me 24. So that means that WX is going to be equal to 24. All right. Then in part B, they're asking us to find MX, okay, and check that WM plus MX will equal to WX. So, okay, kind of carrying off of that, if we currently know that WM is that 16, and we are trying to find that MX, so M all the way to X here. Remember, that's from your center to a side. That's the 1/3. And so since the 16 is my 2/3, I can take half of that to get my MX. Okay, so here, my MX is just going to be equal to 1/2 of that WM. Okay, so that means that my MX is equal to 1/2 of 16, which just means that MX is 8. Okay, so that was one part of what they wanted. Then they wanted me to just check and make sure that they will actually give me that part plus part equals to the whole. Okay, so here we have that my WM is that 16 plus my MX, which is that 8, should be equal to WX, which we found in part A is 24. So 16 plus that 8 gives me 24, which is equal to 24. Therefore, we have checked and proved that they will add up to give us that 24 that we got for the whole. All right, the final part, okay, part C, we have that if my is equal to 6x squared plus 9y, we're going to write an expression so we don't have to solve for x and we don't have to solve for y. We're going to have those in our answers that will represent MO. Okay, so let's look here. We are trying to find from M all the way to O. Okay, so that is going to be from the vertex to the center. That's a 2/3. And we know currently that from M to Y, this right here is going to be equal to that 6x squared plus 9y. Well, if that's my 1/3, okay, and we are trying to find my 2/3, remember, we can take that 1/3 and we can multiply it by 2 to get the 2/3. So that means that to find MO, we are going to double MY. Okay, so MO is going to be equal to 2 times that 6x squared plus 9y, which when we distribute that, we're going to get that MO is equal to 12x squared plus 18y. And then, like I said, they are just asking us to write an expression for it. And so this would be my answer. I don't have to solve for the x or the y. So that is it for our lesson over our lines of concurrency.